Good evening. So we have discussed about the protocol stack and the different layers and the links. In this session, we are going to discuss on the comparison of SCO and ACL links, synchronous links or circuit oriented and asynchronous circuit or connectionless, which is connection oriented and connectionless. So synchronous connection oriented links and ACL links are two different types of links used in Bluetooth communication, each designed for specific types of data transmission, as we all know as well. SCO links are used for synchronous communication such as transmitting voice data. They provide a dedicated point-to-point connection between the master and slave devices. SCO links are typically used for real-time communication applications where maintaining a constant bit rate and fixed timing is crucial, such hands-free calling or audio streaming. The bandwidth of SCO links is fixed and reserved for the duration of the connection, ensuring consistent transmission of time-sensitive data like voice. ACL links are used for asynchronous communication, which is connectionless, such as data transfer between devices for file sharing, messaging, or internet connectivity. They support packet switched communication and allow for variable bandwidth usage. ACL links are more flexible compared to SCO links as they can handle various types of data traffic with different priorities. Unlike SCO links, ACL links do not guarantee fixed timing or constant bitrate. Instead, they adapt to the data traffic and allocate bandwidth dynamically based on the request or requirements of each packet. This is the major difference between SCL and ACL links. So next topic is on ACL setup under LMP. The process of ACL is can be explained in different stages. So the process can be broken down as follows. Asynchronous connectionless setup in Bluetooth communication focuses on the layers mentioned here. The link manager protocol, host controller interface, and L2CAP logical link control and adaptation protocol. So this way, the ACL or the an asynchronous connectionless setup can be segmented. The first one is link manager protocol. Link Manager Protocol LMP operates within the Link Manager layer of the Bluetooth protocol stack. It handles tasks related to link setup, link configuration, and link supervision. During asynchronous connectionless link, LMP is responsible for negotiating parameters such as connection interval, slave latency, and supervision timeout between the master and slave devices. LMP manages a exchange between the master and slave devices to establish ACL connection and configure it according to the negotiated parameters. This picture represents the ACL setup under LMP. So the layers are configured between master and slave. LMP setup connection, optimal switch circuitry, etc. setup complete. So in between, the master sends LMP host connection request. Slave accepts the request and master slave switch accept and additional transmission has been established. By this way, the LMP setup is complete. So the next layer is host controller interface, or the next segment is host controller interface. HCI is an interface between the host, typically the operating system or application, and the Bluetooth hardware controller. It consists of a command interface and an event interface. HCI commands are used by the host to instruct the Bluetooth controller to perform various actions such as scanning for devices, establishing connections, and configuring connection parameters. During ACL, the host sends HCI commands to the Bluetooth controller to initiate the connection process and provide configuration parameters registered by LMP. HCI events are generated by the Bluetooth controller to inform the host about the status of operations such as connection establishment, success or failure. This picture, open host controller interface, resides between the Bluetooth controller and Bluetooth host. Example, PC card and PC. In integrated devices such as Bluetooth capable mobile device, this interface has little or no importance or significance. This interface lies between L2 cap layer and link manager layer, whereas L2 cap layer is the host, where link manager layer acts as a controller. This host interface has no importance in mobile devices. So the next topic is on processors. Logical link control and adaptation link protocol. And before that, we'll look into that. Bluetooth systems consists of mainly two processors. The higher layers of the protocol stack depends on L2 cap SDP or FCOM are run on the host devices processor. The lower layers of the protocol stack depends on baseband and radio, and those two run on specific Bluetooth hardware. HCI provides an interface between the higher layer and the lower layers of the protocol stack. Right? So this picture represents or elucidates the stack arrangement and entire configuration process. So the next layer is logical link control and adaptation protocol, L2 cap layer. L2 cap operates above the baseband and link manager layers in the Bluetooth protocol stack. It provides a multiplexing capability for higher layer protocols and services. During ACL setup, L2 cap is responsible for creating logical channels over ACL link, which can be used by higher layer protocols for data exchange. L2 cap ensures that data packets from different higher layer protocols are properly multiplexed and demultiplexed over the ACL link. This picture clearly explains the